Is my screen visible to you?
Yes, ma'am, it is visible.
Okay,
Yes, ma'am.
Yes, ma'am.
Yes, sir.
So I am also started the recording, the class. So the code for this subject BT301 Life Sciences, and basically this subject for your section, I don't know about other sections, for your section is I, right? For section I, there are three instructors, three professors who will be teaching you. So myself, Dr. Amita Barik, and then there are Dr. Monideepa Ghosh, and we have Dr. Surabhi Chaudhary ma'am. Okay. So this entire subject, entire life science subject has been divided into 6 modules. I guess you all have the syllabus with you. You must have downloaded it from the website, isn't it?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Good. So we
Yes,
have
ma'am.
6 modules. First is cell biology, second is biochemistry, third microbiology, fourth immunology, fifth is molecular biology, and sixth is bioprocess development. So I have also mentioned the professor's name who will be teaching which subjects. So I will be basically teaching you biochemistry and molecular biology, and microbiology will be shared between me and Dr. Ghosh. And the last module, that is the bioprocess development, will be taught by Dr. Surabhi Chaudhary. Right? Okay. So uh, it might so happen that I might take some Thursday class or my Tuesday class, or Dr. Ghosh might take. Okay, whatever is the thing, we'll be informing you. Okay. So it might so happen that biochemistry and as well as cell biology goes simultaneously. So I will be teaching one class in biochemistry and ma'am will be teaching cell biology also. It's not like that I will be first finishing biochemistry and then we will be going to cell biology. Is that okay? Any more doubts regarding these things,
Oh,
class?
okay,
No,
ma'am.
ma'am,
No,
it's
ma'am.
okay.
No, ma'am.
Okay, very good. So let's start with life science. Yeah. There are two books for biochemistry which I will be starting. So I will be starting with biochemistry today. There are two books, Leninger, Principles of Biochemistry, and there is another book, very good book by Stryer. You can get these books, the soft copies from online also, and also if you are coming back to the institute, you have the copies at the our library. You can go through these books. So these are very very good books. The basics have been very well described in the books. But yes, some of you might get scared, ma'am, बहुत मोटा book and all that. So for those, there are other books also. I will be usually telling you the names, but these are very good books which have all the information regarding the biochemistry. Hmm. I hope. How many of you had biology in your class 11th and 12th?
I had.
You had? I mean,
And
do you
Me
just
too.
I
want
had.
to have some
Ma'am,
idea?
me too.
I have, ma'am.
I had.
Okay, at least how many? 10 to 20% students had biology? No? Okay, anyways, do not worry if you do not have biology in your class 12. This is not going to be very tough. At least biochemistry, I am assuring you, because it is more of chemistry, little of bio. So I guess all of you had chemistry in your 11th, 12th, so I don't think it will be any
Yes, ma'am.
difficult thing for you. Let's start with, this is something I always ask my students. So what is your favorite food? I guess all of you had a good yummy breakfast in the
Pani
morning.
puri.
Pani puri. You had pani puri in the morning? I don't think so. You had
Banana.
pani puri in the morning?
Aloo paratha. Banana,
Madam,
ma'am.
apple.
Aloo paratha, banana, and
Apple.
all that. Some had healthy food, some had junk food, and all that. Okay, good. This is this
Ma'am,
picture
Momo.
morning. Momo. Okay. So I do not have a Momo picture over
Ma'am,
here.
cereals.
Hey,
Cereals,
butter.
Biryani.
Madam, apple. Madam, apple.
Chocolates.
chocolates, yeah.
Oatmeal.
What else? Oatmeal, very nice. Who else?
Oatmeal
What
and
else?
fruit.
Uh-huh.
Poha.
Oh, wow. Are you from North India?
And pasta.
Yes, ma'am.
That's nice. Okay, no problem. So everyone had good food in the morning, and yeah. So can you just tell me why did I keep this picture over here and I'm asking you your favorite food? What is the correlation between this and your
Now, on
subject?
the right side, there are junk foods, and on the left side, there are healthy food. As
Okay,
per the.
healthy and junk food. So how do you classify this as healthy food and how do you classify this as junk food?
The
by
junk food and
calories.
saturated fats.
Ma'am, which has fat more and vitamins and minerals less?
Okay.
Oily food.
We should
Oily.
look for balanced diet.
That
Nutrients.
is it. So
Less side effects.
let's side
Lack
effects.
of lack of
Fats are
nutrients.
Lack of nutrients. Okay. Please.
trans fat and unsaturated fiber. Ma'am.
Okay, so someone entered into the deeper meaning, the saturated and unsaturated fats. Very nice, good. Okay, so you guys, did you join the fitness program yesterday? There was a webinar on fitness
Yes,
program.
ma'am.
Yes, ma'am. 7 to 9.
Uh-huh.
Yes,
So there were some doctors telling about these things, right? About your stress,
yes,
about your food
Yeah.
habits, and your exercise and all that. Did you listen to that
yes,
carefully?
ma'am.
Yeah. So that is good. So
Yeah,
you should
ma'am.
be
Good
very much
holistic
careful about
living.
your health. And once you return back to the institute, you will find a green, very green environment over here, and you can just utilize it, go for jogging and exercise. Acha. So the reason I shared you this slide is that, if you go into the deeper thing, as someone said that these are junk foods and these are things, but if you look into the composition of this food, if you categorize the composition, so they fall into four different categories, isn't it? Can anyone please tell me what are the categories? Anyone, any idea? What are the food? What are the composition of this food? For example,
Carbohydrates, proteins, fat.
carbohydrates, yes.
Carbohydrate,
Proteins,
protein,
vitamin,
fat,
lipid,
Fat,
fat,
lipids. Okay, very
fat,
nice, very
lipid.
good. Yeah, so
water.
next time when we are going for this thing, the people will say, okay, should cut down your carbs and all that, go for protein diet, isn't it? When you are going
Yes,
for the
ma'am.
healthy things. So we will be studying about these things in details. What are carbs, what are proteins and fats and lipids and minerals. So basically, food is composed of four major biomolecules. Let's say we have carbohydrates, as say someone said, we have proteins, we have lipids, fats, and then we have also nucleic acid. Okay, so we will be in biochemistry module, we will be discussing about these four major biomolecules. So this major biomolecules are actually macromolecules. Macromolecules in the sense they are big molecules. So we will be starting with the introduction to this major macromolecules, the four major macromolecules. That is the carbohydrates, proteins, lipids, and the nucleic acids. Some introductory slide. So I guess all of you are aware of this, the famous periodic table, which listed the different elements, and I guess some of you must have marked it up also. At least 20 or 30, 30 elements must have been there in your mind,
Ma'am.
right? So here
Yes, ma'am.
in this periodic table, I have highlighted the top five elements that are present in the human body. So yellow boxes, if you go for the hydrogen, then carbon, nitrogen, oxygen, and calcium, these are the top five elements that are present in the human body. The green boxes then represent the second top five elements present in the human body. Let's say sodium, potassium, then we have phosphorus, sulfur, and chlorine. Then we have the blue boxes, which are actually the trace elements that are actually required by the human body. So you can see here magnesium, iron, copper, zinc, etc. And then we have our highlight boxes, which are actually the elements that are actually not good for the human body. They are deleterious to the human body. Okay. So now when we are looking for a typical bacterial cell, bacteria. So bacteria are microbes. So
What
bacterial
about the
cell.
white ones?
Sorry.
Ma'am, what about the white ones?
So white ones again they have their own significance and all that, but here we are just listing for whatever are necessary or whatever we need. Okay. So if we look into the typical bacterial cell by dividing into the composition wise, then we can see that 70% of a bacterial cell is composed of the water molecules, and rest 30 are actually the chemicals, which are actually the macromolecules such as polysaccharides, the carbohydrates, proteins, RNA, DNA, phospholipids, ions, molecules, and etc. etc. Okay, so majority actually, if you know, go for the organic mass that is composed by the macromolecules. Yeah. So what are we going to study in this module? We will be studying what are macromolecules, why they are important, and a little bit about their metabolism. Okay, so let's start molecules. So before we start, there is some major, that is the thing that is common in all the macromolecules things. So there are two reactions which are actually the key reactions in all the metabolism. You are aware of this: condensation and hydrolysis. Condensation in the sense that it is actually joining two molecules with a release of water molecule. Okay, and in hydrolysis, molecules are actually splitting into two different two or more molecules and with the help of water molecules. Okay, so this reaction, I guess all of you are aware of it. So if you look into the how the different molecules are actually affecting bigger molecules, so these are the actually key reactions in all the metabolisms: anabolism and catabolism, or you can say that condensation, hydrolysis reactions. I guess all of you are fine with this. I'm going in a good pace or very slow,
Yes,
very
ma'am.
slowly, quick. It's fine, all of
Yes,
you.
fine. Yeah.
Fine.
Yes,
Okay.
ma'am. Fine, ma'am.
So can anyone please tell me what is actually common to all macromolecules?
Carbon,
Sorry,
carbon,
carbon. Okay,
organic
Hydrogens.
compounds,
hydrogen.
organic compounds,
Okay.
all.
Mhm. But if I tell you, okay, macromolecules are actually also known as polymers. Then can you tell me what is the common factor in general? I'm not telling about the composition. What are macromolecules?
CH2O taken in.
They don't.
You're
They
taken in,
form.
that is fine.
They
You have
form.
known very much good about
Cherry
it.
linkage between
And tell us,
They are
let's say I have a macromolecule. What is it actually composed of? So macromolecules are
carbon,
actually
Chains of
hydrogen.
molecule,
monomers.
isn't it?
water,
Yeah, someone just did it. Yes. Macromolecules are bigger molecules. What are the smaller molecules?
Monomers. Chains of
Mono.
monomers.
Monomers.
Monomers. Exactly. That is what I wanted to ask.
yes, sir.
So if you look into this macromolecules, these are bigger molecules, so the bigger chains, they're known as the polymers, and these are made up of what do we say as monomers, which are actually the building blocks. So small molecules or the monomers join together to form a big molecule, which is known as a polymer. Clear?
Yes,
Good.
ma'am.
So when we are talking about these macromolecules, as we said, carbohydrates, proteins, lipids, and all. So what are the monomers? So if we classify carbohydrates, lipids, proteins, and nucleic acids, so on the right side we have listed here monomers. So carbohydrates are actually formed of monosaccharides. Lipids are formed of fatty acids and glycerols. Proteins are formed of amino acids, and nucleic acids are formed of nucleotides. Okay, so what happens here? I'm telling you from my past experience of correcting the papers of my students. This is a basic. I guess many of you are aware of this. Whoever taken biology feels okay. कुछ भी नहीं है. Very much basic question. But then again, there are many students who actually, I don't know why they skip or something. This question, if I ask in the exam, I guess that around 60% of students answer it wrong. I don't know why. I have given the slides, I'm doing the recordings and all that, but maybe they are not studying well and all that. But nucleic acid are the macromolecules and nucleotides are the monomers. Clear? Don't get confused. And sometimes they don't write the spellings also properly because nucleotide spelling always will be written something else and all that. So monosaccharides are the monomers of carbohydrates, lipids are formed of fatty acid and glycerol, proteins of amino acid and nucleic acid of nucleotides. We will be studying each of these macromolecules individually, one by one. So we'll be starting with carbohydrates first. Carbohydrates, or known as saccharides, they are commonly known as the sugars. If we look into the Greek, the saccharine means the sugar. So most of the things have been derived from the Greek language. So carbohydrates or saccharides are actually commonly known as sugar. Basically, they are aldehyde or the ketone compounds with multiple hydroxyl groups. So you know what is an aldehyde is, what a ketone group is, isn't it? This is the basic
Yes,
chemistry. I'm
ma'am.
not going to detail. So with
Yes,
aldehyde and
ma'am.
Ma'am.
ketone, we have some hydroxyl group, and they are actually forming the carbohydrates. And carbohydrates are actually actually the most of the, or they are the most abundantly found because they are most of the organic matter on the earth are form of carbohydrates. Now some bullet points about carbohydrates which is very much necessary. Carbs actually provide energy. So next time when your mother tells you to eat rice and all, so do not avoid it. Okay, so you are getting some energy. Yes, because they are the best source of fuel for the body. They also help us to digest the proteins and the fat. But again, there are pros and cons. So if you eat more of the carbohydrates that are needed for your energy, so that extra amount of carbohydrates is stored in the liver or the tissue as the fat. Right? Are you getting my point? So jitna chahiye utna hi khaiye. Don't eat excess of the carbohydrates, but until unless else it will be stored as your fat in your tummy, and you will be again scared for the calories. Okay, so carbohydrates, how they are produced. So mostly carbohydrates are produced through photosynthesis in plants. I guess all of you are aware of this typical reaction where carbon dioxide and water molecules
ওগুলো উঠে না, ওগুলো
interact
স্থির
with the
রাখো।
energy and then
ভাগ তুমি ছাড়ো।
release of glucose with
কি বাজে
oxygen.
ম্যামটা,
So
এত
basically
ঝগড়ুটে না
typical
ম্যামটা।
photosynthesis reaction. And
প্রচুর
that is
দেখি
the reverse one
ঝগড়ুটে,
is the
সবাই বলে
respiration,
বাজে ম্যাম।
which actually we breathe without the carbon dioxide. So carbohydrates are also the major source of energy from our diet, and CnH2n this is the ratio how carbon, hydrogen, and oxygen are actually present in the carbohydrates. Someone already told us, right? CnH2n. This is the typical formula of how a carbohydrate formula is there. Composition. Yes. So if you look into the different categories of carbohydrates, so basically they are classified as monosaccharides, disaccharides, oligosaccharides, and polysaccharides. So monosaccharides means the basic ones. There is no hydrolysis. This is the simple carbohydrates. Okay. So they are actually the monomers how the carbohydrates form. Disaccharide, what happens that when two monosaccharides actually interact to form a disaccharide. So two monosaccharides are there to form a disaccharide. Oligosaccharide actually 2 to 10 monosaccharide interact or they find to form a oligosaccharide. And then we have polysaccharide where more than 10 monosaccharide units interact to form a polysaccharide or we can see the carbohydrates. Clear? Class? Okay till now?
Yes, ma'am.
Carbohydrates,
Yes,
monosaccharides,
ma'am.
disaccharide,
Yes,
oligosaccharides.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Very good.
Yes, ma'am.
Yes, ma'am.
So again, this is a tabular form where I have shown you the carbohydrates, the monosaccharide, 1 sugar molecule, disaccharide, 2 sugar molecule, oligo is for 2 to 10, and polysaccharide 10 or more sugar molecules. So basically in my class, I will be in this session, I will be going through these categories, the ones that are marked in the red one. So we'll be learning more about the monosaccharides, which are glucose, fructose, and galactose. Under the disaccharides, which are actually composed of 2 sugar molecules, we'll be learning about sucrose, lactose, and maltose. And among the polysaccharide, we'll be discussing about the starch, glycogen, and cellulose. Okay. And there are many more monosaccharides, there are other disaccharides, oligosaccharides, and all that we are not going to discuss. But if you are interested, you should learn about it. Okay. There are very good books. But for the time being, in our session in this class, I will be teaching you this many. So starting with the monosaccharides or the simple sugar. So carbohydrate that cannot be hydrolyzed or that cannot be slitted into any smaller carbohydrate is a monosaccharide. So it's the basic building unit to which carbohydrates are formed. So monosaccharides are the simplest sugar. They are actually the 9 carbon atoms. Mostly they are having a carbonyl group, okay, which can be a keto group or a aldehyde group. And there are several hydroxyl groups, as you can see over in this chemical composition. And as you say, CnH2n ON is the chemical formula of this. So yes, so monosaccharide actually, if you categorize them, so there are two forms. They can be aldose or a ketose, as I said. So aldose monosaccharide are something which are having a aldehyde group and obviously many hydroxyl groups. And ketose monosaccharide is having a ketone group and obviously many hydroxyl group. So this is how it looks like. This is a typical aldose, how it looks like. So you can see this aldehyde group, CHO group is formed like this. And in keto group, we have this C double bond oxygen keto group, and obviously we have 5 to 6. So based on the carbon atoms, they are named accordingly. So if I have here in this left hand picture, I have how many carbon atoms? We have around 4 carbon atoms. So this is a tetrose. So if I have 3 carbon atoms, so it is a triose. If it has 4, then it's a tetrose. Then it's a 5 is pentose, and then we have 6 and hexose and all that. Okay. So since it is having 4 carbon atoms, it's a tetrose, and since it is having a aldehyde group, it is a aldotetrose. Similarly, over here there are 6 carbon atoms in the right hand side picture, so it is a hexose, and since it is having a keto group, it is a ketohexose. By then again they are having different names, so this aldotetrahydrose is named as erythose, and this ketohexose is known as fructose. Okay. So
Yes.
we go for simplest aldose. The simplest aldose is glyceraldehyde, and the simplest ketose is dihydroxyacetone. I guess these things you have learned in your chemistry as well, isn't it? Or not?
Yes,
Yes,
ma'am.
ma'am.
Yes,
You
ma'am.
have.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
So you
Yes,
are all
ma'am.
aware of
Ma'am.
glyceraldehyde and dihydroxyacetone structures as well. You can see the CHO group of the aldehyde, and you can see the keto group in the dihydroxyacetone. The chemical formula for both of them is same, C3H6O3, like CnH2n and ON, isn't it? But only the conformational differences because of the functional group. So these are known as the constitutional isomers. The constitution is same, but they are having different groups, so they are known as constitutional isomers. Yes, there are some important monosaccharides, as I told you beforehand, that we'll be discussing about 3 major monosaccharides: glucose, fructose, and galactose. So starting with the glucose, which is also known as dextrose.
Ma'am, one
Which,
doubt is there,
yes,
ma'am.
yes, yes,
Ma'am, in
please.
the previous slide,
Yes,
ma'am, are they not functional isomers? Why constitutional?
yes, you can say that also.
Oh,
Yeah. Functional. Yeah. So we are talking about the glucose, which is also known as a dextrose. It's a aldohexose. So this is one of the most evident monosaccharide. I guess all of you are aware of glucose. So it is found in fruits, vegetables, corn syrup, honey, etc. And also it forms a disaccharide known as sucrose, also lactose and maltose. This is common in all these 3 disaccharides. We will be learning about disaccharides soon. So if you look into disaccharides, so sugar is a major component of these 3 disaccharides like sugar, lactose and maltose. And also sugar is the main constituents of the different polysaccharides such as starch, cellulose and glycogen. So this is the structure of glucose. It's a aldohexose, so 6 carbon atoms are there, and it's a having a aldehyde group, CHO group is there. Okay. Now coming to the another monosaccharide, which is fructose, which is again having the same formula as glucose, 6 carbon atoms with double hydrogen and oxygen are 6. So fructose, as I said, is a ketohexose. So we are having a ketone group. Okay. In glucose we had a aldehyde group, and in fructose we are having a keto group. So this is the sweetest of all the carbohydrates, and it is found in fruit juices and honey. So also known as the fruit sugar. And in the bloodstream, what happens is that this fructose is actually converted into the isomer. Its isomer, which is glucose. Okay. And also fructose and glucose combine together to form a disaccharide known as the sucrose. We will be studying soon. So these are about the fructose. So glucose and fructose are actually isomers. One is having aldehyde group and one is having keto group, and they are having the same chemical formula, C6H12O6. So we have another aldohexose known as galactose, which is actually also a aldohexose in the sense that it is also having a aldehyde group. it has all the structure similar to glucose, except that at the fourth carbon atom, you can see the OH. 1, 2, 3, 4. So you can see how this OH is formed in galactose, and you can see over here. In glucose, and the fourth carbon atom, we have hydroxyl group on this side, and on galactose we have on the this side. So for the OH group, the structure, that is a typical difference between the glucose and galactose. So galactose is actually, we do not see them in the free form in the nature. So they exist in the cellular membranes of the brains and the nervous systems. It actually combines, and for the disaccharides, so galactose actually combines with glucose to form the lactose, which is actually the sugar that is found in the milk. It's actually disaccharide. We'll be learning more about that. So glucose, fructose, galactose, all these three have the same chemical formula. Glucose and fructose, how they are different? Because of the aldo group and the keto group. And how glucose and galactose are different?
C4 primer. C4 primer.
C4 position is
C4
different.
position. Yes, different. But both are aldohexose. Okay. So clear for this time? I mean, for all the monosaccharides? Any doubt till now? Glucose, fructose, galactose.
Ma'am.
Confused to
No,
you?
ma'am.
Okay. Okay. So why I am focusing over and asking you these things, that see, एक बार आप क्लास में पढ़ लो, then you go revise it once and make your notes whatever. एक दिन में at least 10 minutes आप दे दो, whatever you are studying. At the night you go make some notes. So what it happens that जो पढ़े उसको revise एक बार कर लीजिए, तो it will so happen that when you are writing for the exams, आपको इससे ज़्यादा मेहनत नहीं करनी पड़ेगी. Are you getting my point? So ये छोटे छोटे चीज है, एंड ये तो इजी था, पढ़ लिए, कॉन्फिडेंट ओवर कॉन्फिडेंट हो जाता है, फिर बच्चे मिस्टेक कर देते हैं. सो ये वाला चीज को ध्यान रखिए, एंड जस्ट एटलीस्ट गिव 10 minutes. आई एम नॉट गोइंग फॉर 1 hour or half an hour and all that. Just 10 minutes. एक बार रिवाइज कर लीजिए whatever you have studied. Make some notes because that will be very much useful for you for your end exams and also for midterm. Yeah.
पीडीएफ मिलेगा ना मैम?
Sorry.
पीडीएफ इसका
Ma'am, you are
Ma'am,
muted.
you're muted.
Ma'am, you have muted yourself.
Okay. Aditya is reading something. Raising his hand. Aditya, any questions? Aditya? No? Okay. Again, he has raised. Okay. So what I was telling, we are discussing about the monosaccharides. So monosaccharides, the 3 monosaccharides are done. Moving to the, yeah, this is something important. The sugar molecules actually tend to form a ring structure in the water. So what happens in aqueous solution, this aldehyde or the ketone group of the sugar tend to react with the hydroxyl group of the same molecule, thereby forming a closed ring-like structure. You can look into this. So what is happening over here? The second one, this is the structure that we learned. And what is happening that this aldehyde group or the ketone group is actually interacting over here to with the release of this release, I'm telling you. So they again react with this hydroxyl group of the same molecule to form this closed like ring-like structures. Okay. So if you can write this structure or this structure also, you are getting marks in the exams. So whatever structure you write, you either write in the total form or like in the ring-like structures. Okay. And you have to be careful with the numbering of the carbon atoms because you are looking for the from the series, so that you have to be careful from where it is starting. Okay. Yeah. Someone was asking about the isomers. So we know about isomers that they have the same chemical formula but different structures. And also if they have the mirror images, they are also known as the optical isomers or the stereoisomers. So if you can in sugars, mostly we are having a lots of isomers things and all that. So stereoisomers actually the term is because of this mirror thing and all. So we can have D glucose and L glucose. So mostly they are differing, the isomers are differing their spatial arrangements of the atom molecules, because as I discussed earlier, glucose, galactose also have mannose. They have actually the same formula C6H12O6, but the different arrangement of the group atoms. So this is how the isomers are there. And when we look for the physical properties of the monosaccharides, so these are actually colorless, they are sweet, they are crystalline solids, they are actually polar with high melting points because we have hydroxyl groups. So they are actually polar. Polar in the sense that they are hydrophilic or water loving, and they are having high melting points. Also, since polar, that means that they are hydrophilic, they are soluble in water, and actually insoluble in non-polar solvent, all because of the hydroxyl groups. Clear? So these are some of the properties of the monosaccharides. We discussed about the structures. What three monosaccharides we discussed, class? Just a quick reminder. Class, am I audible?
Glucose,
Yes, ma'am.
fructose, and galactose.
Galactose.
Yes, glucose, fructose, and galactose. So sometimes what happens that student may make mistakes like galactose को disaccharide लिख देते हैं and then they forget what, I don't know what happens. Glucose, fructose, galactose are monosaccharides. Galactose, remember, it's a monosaccharide and not a disaccharide. Yes. So what are actually disaccharides? So as I discussed, monosaccharides, when two monosaccharides combine together, they form a disaccharide, which are actually linked together with the help of a glycosidic bond. So remember, carbohydrates are actually bigger molecules, macromolecules. So the bond between the monomers in carbohydrates is the glycosidic bond. Okay. So glycosidic bond is a type of covalent bond. Actually, it is joining two or more monosaccharides to form the bigger molecules. So as I said, so what type of reaction over here it is taking place with the release of water molecule?
Condensation.
Sorry?
Condensation. Condensation.
reaction.
So water is released when two monomers are joining together. So there are three disaccharides that we are going to discuss in this class. There are many more. So maltose, lactose, and sucrose we will be discussing. So what are composition of maltose, lactose, and sucrose? So all these three have this common factor known as glucose. Again, in maltose, actually there is another glucose molecule. So two glucose molecules interact to form a maltose molecule. In lactose, we have glucose and galactose, and in sucrose, we have glucose and fructose. Okay, so these are the monomers which are actually interacting to form this disaccharide bonds, and this with the release of a water molecule. And these are actually joined together with the help of a glycosidic bond. So do not get confused whenever exams questions comes, which is glycosidic bond, what is phosphodiester bond, and there are peptide bonds and all that. So people get confused and they just mess up with all these things, and that will jump out of marks data is 0. So of these three disaccharides that we are going to study, maltose, lactose, and sucrose, maltose and lactose are actually the reducing sugar. Can anyone please tell me what are reducing sugar?
Which give a positive tolerance and failing
For
test.
tolerance and Benedict test positive, they are reducing sugar.
So in your chemistry classes, we have done this experiments, Benedict test and
Yes,
all.
Yes, ma'am.
Yes, ma'am.
Benedict.
Yes,
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 ma'am.
ma'am.
It was
Yes,
fun.
ma'am.
Yes, ma'am.
Okay, good.
Yes, ma'am.
So, but last 2 years has been a pandemic year. So how did you do this chemistry experiments?
Not done.
I am
Only
dropper,
the
ma'am.
Biology lab
I am a
was there.
dropper. I am
I
a
am dropper,
dropper.
ma'am.
I am a dropper.
Dropper, ma'am.
Okay, so most of the people are droppers, so
We
they
are
have done,
dropper.
and those are freshers they have seen through YouTube tutors and the teachers performing student.
Only done in
Okay, very
theory,
good.
ma'am.
Sorry,
I'm also class 11.
in class 11th you have studied. Okay, good. So these are good. I mean, chemistry experiments are fun, really fun. I loved it. So we have sucrose, which is actually a non-reducing sugar. So what is reducing and non-reducing? We'll be learning more detail. So reducing sugar actually is something that is actually capable of acting as a reducing agent. Okay, reducing agent in the sense that this sugar actually has a free aldehyde or a free ketone group. So it acts as a reducing agent, and hence it is known as reducing sugar. So if you look into monosaccharides, so all the monosaccharides have free aldehyde or ketone group, isn't it? So all the monosaccharides are actually reducing sugar. Okay. So since they have a free aldehyde or a ketone group. Among these disaccharides, we have maltose and lactose, which are reducing sugar. They are actually having one of their two anomeric carbons. We will look in the structures again. So they are actually involved in glycosidic bond. So they can convert, that's why, into an open chain form, also into a with an aldehyde. Sucrose on the other hand is a non-reducing sugar, because what is happening here that the glycosidic bonds between these anomeric carbons, there are glycosidic bonds, and they actually cannot convert into this open chain form with aldehyde group. So, okay, it is always into this cyclic form. So cyclic sucrose is not a reducing sugar. If you look into the structure, maltose is composed of two glucose molecules. So we have glucose, alpha glucose, two alpha glucose are interacting here. You can see this is the closed chain form structure of glucose. Use some highlighter here. Okay, so this first carbon and the fourth carbon actually forming a glycosidic bond. So how they are renaming this bond as, since it's alpha and the 1 and 4, so 1 comma 4, we are giving this carbon name atoms which are actually interacting, and the 1 for glycosidic bond that is formed in the maltose with the release of a water molecules. So when we are looking for the bigger structure of the maltose, so these are actually obtained from the breakdown of the starches. So starch is a polysaccharide. We will be learning about starches. So starch, when it breaks down, it forms a maltose. And maltose, we are using them in cereals and candies and all that. As I told, this reducing sugar, you can see this the carbon 1, this one can open to form a free aldehyde to oxidize. So this can open up, and this is that's why it's a reducing sugar. So it's already, I believe it's 11:45. Do you have any class right now, or can I take 10 more minutes?
Ma'am, we have classes from
You have
Yes,
12.
ma'am, we have
electrical
classes after that.
Classes.
electrical
Is that
technology
11:45?
class. Sorry, electrical.
No, I am asking
Electrical
you, when
technology.
do you have the class?
It is
Next
from
class?
12.
12
12.
12.
It's from 12 to
12.
12. So what do you want me? You need a break? Should I stop over here and resume the class in the next one, or should we continue with this?
No, ma'am.
Continue, ma'am. Please continue,
Take
ma'am.
more.
Continue.
Take more.
Continue, ma'am.
Yeah, so I'm just finishing this disaccharides. That's over for today's class. So it will be useful for you only. So since we are going in a flow form, okay. So in a flow. So second disaccharide is lactose, which is formed of glucose and galactose. So whatever here it is actually, it's a beta galactose and alpha glucose are interacting. So it will be a beta 1 4 1 and carbon first carbon and fourth carbon are interacting, again 1 4 glycosidic bonds. And lactose actually is found in milk and milk products. It has almost no sweet, but again it is a reducing sugar, as I told you. So carbon 1 actually can open to form a free aldehyde to oxidize. Okay, so this is the milk sugar, the lactose. Then coming to the third one, which is the table sugar, which are actually we are eating every day, is the sucrose, which is actually obtained from the sugar canes and sugar beets and all that. So it is composed of two sugars which are known as glucose and fructose. If you look into the structure over here, so the first carbon of glucose and the second carbon of fructose are actually forming this glycosidic bond. So it is a beta 1 to glycosidic bond, alpha sugar, alpha glucose and beta fructose are actually interacting to form a sucrose molecule. And you can look into the structure. This is non-reducing. Why? Because this carbon atom, the first one, cannot open to form a free aldehyde to oxidize. Hence, it is a
Yes,
non-reducing
ma'am.
agent or
Ma'am,
non-reducing.
maybe it is a doubt.
Yeah.
Ma'am, what does that mean? Carbon 1 cannot open to give free aldehyde to oxide. The criteria for distinguish between reducing and non-reducing sugar.
So you can see this bond, how this bond has been formed. तो कार्बन का पूरा चारों valency is occupied, isn't it? The structure is such a
Yes,
way
ma'am.
that it cannot open to free aldehyde, open up नहीं हो रहा है to give it up to into a oxidize.
So, ma'am, in the previous slide where there was maltose, how it will open, and here it will not open.
Here it
There
will
should
open
be a
because यहाँ पे, sorry,
there should be a free hemiacetal group, right?
yeah. So they will be found. If you look into this bonding, so it will open up to form a free aldehyde. I will show you the reaction next time when I have this pen paper. Okay. So I can just show you how it's actually happening the reaction because I don't have this pen thing over here right now to show you. Okay. In the next class, I will be showing you how it's opening up. So that it is actually forming this free aldehyde group is giving it a free aldehyde group, and that is why it is known as a reducing sugar. Here it is bonded and it is not giving the free aldehyde. Clear? So in the next class, remind me. I will just show you. I will just put on this pen and in the MS Paint, I will show you that reaction. Okay? Okay. Okay.
Okay.
Class. Yeah.
Okay, ma'am.
Yes. So polysaccharides thing. Yeah. Yeah. Sure. Polysaccharides thing we will be discussing because again we have some more classes in this. Yeah. Yeah. Polysaccharide. Let's keep it here only. So that we'll start in the next class. We need to learn more in the details. So till now, monosaccharides and disaccharides. Any doubts, class?
No, ma'am.
No.